these problems, we're going to use a formula commonly known as Heron's formula to find the area of the triangles. And Heron's formula is based upon what we call S, which is the semi-perimeter. And semi-perimeter is just half the perimeter. And the formula is area equals the square root of S. And then for each side of the triangle, you subtract that away from the semi-perimeter. And so in this case, the semi-perimeter, well, 8 plus 9 plus 11 equals 28. So half of 28 is 14. So S equals 14. And so our area is going to be 14 times, well, 14 minus 8 is 6. 14 minus 9 is 5. And 14 minus 11 is 3. And so 14 times 6 times 5 times 3. It's usually a lot easier to find factor pairs to do your simplification. And so we know we have a 2 in both 14 and a 3 in 6, which gives me a 2 times 2 is 4, so the square root of 4 is 2. Same thing with 3 times 3 is 9, the square root of that is 3. And then what's left, so I've gotten rid of the 2's and the 3's, is 7 and 5, and so it's root 35, and so the correct answer to this problem is going to be 6 root 35. Very simple formula, usually a good idea to try to do your square root simplification before you multiply the number out. The next one, the numbers are pretty big, but it's still very doable. You've got 42 plus 26, which is a semi-perimeter of 68, so the semi-perimeter is 34. And so that's going to give us area equals the square root of, and it's 34. And then you're going to subtract each of these from 34. Well, 34 minus 17 is just 17. 34 minus 25 is 9. 34 minus 26 is 8. And all of a sudden, if we do what I said in the last problem, which is take out factor pairs, well, here, the square root of 9 is just 3. There's a 17 in 34. And so if I take two 17s out, I put the 17 out front. And then I'm left with 2 times 8, and 2 times 8 is 16, and so we know the square root of 16, that is 4. And so now we realize that the area of this triangle with side length 17, 25, and 26 is not only findable, it's actually an integer. And so you do 17 times 12 and get 204. And so the area of this triangle is 204 square units. Now, whenever there is an area that is an integer, you could have also done some guessing to get it right. If you look at this problem and you think about the side length of 25 and 26 and 17, and if the area is an integer, that means this height right here must also be an integer. Now, there's no way you can have an area of an integer and that be anything but an integer. And not only that, it actually has to be an even integer. And so if you know your Pythagorean triples well, you know that 25 is the side length of a Pythagorean triple, a couple different ones. But the one that actually is going to work out is what we call a 7 by 24 by 7 right triangle. And then that fits in well because 24 and 26 are exactly twice 12 and 13. And so that means this must be 10. And 10, 24, 26 makes a right triangle. And so now you can see why, because of these two right triangles, that our area is an integer. But again, Heron's formula is plenty powerful to handle that problem.